Alrighty, everyone. So if you have this video from my class, then you should be grabbing your 3.5 notes, and you're going to grab your notebook, and we're going to add this to our exponential functions unit. So go ahead and turn to your Unit 3 table of contents, and we're going to add 3.5 here at the bottom. And this is an intro to I cannot spell today. Intro to logarithms. For me in my notebook, this is going to be on page 21. On your notebook, just look and see what page you are on. And then we're going to go back, and we're going to open up go to those 3.5 notes. So we're introducing logarithms here. This is a drawing of a man named Leonard Euler. The pronunciation I'm not so sure about, but he was a Swiss mathematician back in the 1700s, and he has to do with logarithms. So you're going to see that a little bit today. So our learning target is I can use the definition of a logarithm to convert between logarithmic and exponential forms. So one thing to note, if you think all the way back to our very first unit of the year, exponential and logarithms, in the very first unit of our year, we learned about inverse functions. And so let's add this in. Exponentials and logarithms are inverses. So knowing this and knowing the definition of a logarithm allows us to use both exponentials and logarithms and convert between the two formats for whatever we might need. So that's going to be our focus for today's notes, is just introducing logarithms and seeing how are we able to use what we know already about exponentials and what we are going to learn about logarithms to be able to convert between the two formats to solve whatever problems we might need to solve. Let's go ahead and open up those notes. Let's review our exponential form here. So in exponential form, we have some base b to the x power, and that's going to equal some output a. So b is our base. X here is our exponent, and a is the output. Now, logarithmic form uses b, x, and a, just in a slightly different format. So it starts with some log. So you might have seen that log. When you see log, that's a logarithm. So that log is going to have some base b. And inside of the log is going to be our output a. And that's going to equal our exponent. So a logarithm, when we see what a logarithm equals, we're saying it actually equals the exponent of b that would get us a. When we're converting from exponential to from logarithmic to exponential, one thing I like to think about is kind of this swoop around as we're going. So b to the x equals a as we're going around there. And it's the same thing. The b is still our base. The x is still our exponent, and the a is our output. This is just in a different format. And it uses that logarithm, that logarithm. So we have a couple of special bases that we use. The first one is called our common base. The common base uses 10 as the base. So if we see log with no base, no number down where we see the b, the base is understood to be 10. So for example, if we were to see just log of 100 equals 2, we understand that as the base being 10. We also have something called the natural base, and this uses something that mathematician on the front of our page discovered. The natural base uses Euler's number, which is an E. So if you think back to our first unit when we were talking about functions and function notation, we talked about, hey, you can name functions any letter, but most of the time we don't use E because in math, E represents Euler's number, which is approximately 2.71828. So it's not exactly that, but it's approximately that. So E has similarities to pi in that when we see E, we understand that as equaling this specific number. So pi we know is 3.14159, et cetera, et cetera, et cetera. So we know when we see the value or the symbol pi, that is understood as that number. So in exponential form, we use the E as the base. So an example of that might be, so we might say E to the second power equals, and I don't know what that is off the top of my head. Let me do a quick, because again, it's, this is using this is 2.71828 to the second power. So that is going to be a weird looking decimal, huh? So E to the second power equals about, and so a lot of times we use that, is about equal to 7.389. And in logarithmic form, instead of using log base E, we're going to use ln. So that is understood as the natural log. So this is called the natural log. So an example here, if we use the same thing that we just used above, the same example, but in exponential form, that would say the natural log of 7.389 is approximately equivalent to 2. So just to note, this gets confusing for some students. When you are looking right here at that natural log, that is an L, not a 1. This is not 1n, this is ln, as in logarithm, the natural log. And so we understand that as a base of E. So now here's the nice thing about being able to convert between exponential and logarithmic forms. So using these formats above, we are able to convert between the two formats, and being able to convert between the two formats helps us to be able to solve exponential and logarithmic equations. Think about it. If you have a weird decimal and you don't, like if you have a not easy question, like 2 to the x power equals 8, well, for a lot of us, we can just figure that out. Oh, x has to be 3. But what if you had 2 to the x power equals 3.9? Well, we don't have a way to solve that, so we can use logarithms to help us solve that. Let's look at some examples here of how we can convert from one format to the other. So in number 1, I see that this is starting in exponential form. So I'm going to convert it to logarithmic form. And for these first few problems, I'm going to use the same color coding we did, where the base is in blue, the exponent is in green, and the output is in red. But we're going to step away from that in a little bit too, just to make sure we can see this in just regular writing as well. So if we start here, I know I'm going to have a log Since I'm starting from exponential, I'm going to logarithmic. My base was 2, so it's going to be log base 2 of A, right? If I'm using this format here, log base 2 of my output was 32, equals my exponent, and the exponent is 5. That's all there is to it. We just have to rewrite and be really careful with what goes where. Looking at our second example, I'm starting in logarithmic. So we're going to go to exponential form. So I know that for my exponential form, which I have right here, I'm going to start with my base. So I'm going to go from my base here of 3 to my exponent. I know in the logarithm, the exponent is what the log is equal to. So that is my 4. So 3 to the 4th power equals my output, which in a logarithm is inside of the log. 3 to the 4th power equals 81. Number 3 here is also starting in logarithmic form and is going to exponential form. And you might be saying, but wait, there's a fraction. That's okay. We can get fractions when we have exponents sometimes. Okay, so we're going to go from logarithmic to exponential, so I need to start with my base. Notice here, there is no base, but this is a log, so I know, based on what we said over here, this is going to be my common base. So I know that the base here, since I don't see one, is 10. So this is going to be base 10. My exponent then is a -2 equals my output, which is inside of my logarithm, 1 over 100. Beautiful. For number 4, I'm looking here, I see an exponent, so I'm starting from exponential form, and I'm going to logarithmic. I'm also noticing that I have that e as my base here. So when I have e as the base, I'm going to use the natural log for my logarithm. So I'm going to have the natural log of my output, which was 20.0855, is approximately equal to my exponent of 3. A few more here just to get some, make sure we've got this, and we can write these in all different ways. In number 5, again, I'm starting from exponential. I'm going to logarithmic. Take a moment, pause your video, see if you can write this, and then continue your video and check your answer. So when I have a base 10, I know that base 10 is my common base. So I could write log base 10, but that's kind of redundant. So we understand it as just the log of my output, which was 10,000, equals my exponent of 4. Number 6 then, I'm seeing that ln, so I'd see a natural logarithm. So now I'm going from logarithmic to exponential. I'm seeing that logarithm, or that natural logarithm. So once again, pause the video here, give this one a shot, see if you can convert it from logarithmic to exponential, and then restart your video and see if you got it correct. So when I have that natural logarithm, this is a base of e. So this is going to be e to the 6.26 power, you can have a decimal as a power, is approximately equal to 523. One more example here, and this one does have a variable in the exponent, but that's okay. We're starting from exponential form and we're going to logarithmic. So for this one, by converting to logarithmic form, this would make it possible for me to be able to solve this equation for x. So here, I know my base is 4, so I'm going to have log base 4 of my output, which was 64, equals my exponent of x minus 5. Now, log base 4 of 64 has a value, which means we could, which we will do in a future video, we could finish solving this equation for x. Beautiful. Let's have you pause, put these notes into your notebook, and then go back to Canvas to continue working through your assignments for this module.